it mean to have a 1 in 6 chance of something happening, like these dice being rolled? What does it mean? 1 in 6 chance. We fire this up.
Do it 6 times, it should happen once.
Do it 6 times, it should happen once. Anybody agree with that? Okay, here we go. There. I just rolled 6 dice in Excel. Now, what I did in Excel was I created what's called a random number generator. It's called the ran between command in Excel. You can type in equals ran between, and then you get these random numbers that pop out. I just rolled it 6 times. And what Excel got was it got 3 2s, 2 5s, and a 4. Therefore, David is lying to me. Isn't he? Isn't he lying to me? Because he said if you roll a die 6 times, you're going to get a 1. That's not what you said.
Statistically speaking, though, that's saying over a period of time.
Oh, and that's kind of the important thing to say, isn't it? It is not a guarantee that if you roll a die 6 times, you're going to get a 1, a 2, a 3, a 4, a 5, and then a 6. As a matter of fact, in 20 years of using the simulation, that has happened 1 time. I always start this sheet by pressing it 6 times. 1 time it came up 1, 2, 3, 4, 5, and 6, and I'm like, shit. Shit. I'm not going to do it again. Go ahead, David.
Well, if you roll it 60 times, I bet that number you're focusing on is going to get closer to 10. If you roll it 600 times, it's going to get closer to 100.
Dave, why don't we test that now? Why don't we just test that? I'm going to hold down. Okay, you see what just happened there? As we're rolling, let's get close to what you guys just did. You had 260 trials, right? 260, hang on. There we go. 260. Here's what this is the same thing you guys just did.
Yeah.
This is the same thing you guys just did, but look. Slightly different than yours.
Very close.
But very close within that margin, yeah?
Yeah.
Definitely within the margin. Look at the pie slices. What's happened to the pie slices? They're beginning to even out. That original goofiness of half, a third, and a sixth is now gone and replaced with arguably a sixth, a sixth, a sixth, a sixth. Now what I'd like to do, phone, I want to hold down the F9 button a little while. Let this thing do its thing for a long time. Let it get a couple thousand, 10,000, 20,000 trials, and then come back to it. Go ahead, Dave. What's on your mind?
This also eliminates the possibility of human error, which with rolling die is still totally possible because it depends on how you roll. If you just pick it up and just let it, just toss it, there's a possibility that I got 5 6s because that's probably doing that.
No. You're absolutely correct, David. This removes any what's called non-sampling error from the experiment. If I could just learn VBA, this would not be an issue. Usually I bring a stapler. I forgot to bring it today.
Do you want me to volunteer?
Nah. I mean, yeah. But I have more experiments for us to do.
Do you need something to hold your phone up on the other side?
You can probably
water
put your eye on something.
I'm trying to think. I need something tape.
Must be heavier.
Oh, this. Maybe. Thank you, Kill. Let's try that. Hang on. Yeah, the stapler is perfect. Perfect. Let's let it go. Let it keep going. Now you got to realize that those don't look like they're moving, but they are. Just look at where the change is happening. It's happening in the hundredths or thousandths of a percentage, right? Or I should say the tenths or hundredths of a percentage, the hundredths or thousandths of a decimal. So they are fluctuating. It's just they're not fluctuating. It's what David said. The larger the sample gets, the less they're going to fluctuate because they're honing in on that Tom's 0.16666. Let's let them continue to hone and come back to them, okay? That's okay with you guys? Any final comments on that experiment? Dave, go.
I noticed at the bottom too, like once a certain number gets below where the other ones are, it's hard to catch up because it is more probable that it's going to happen evenly. So once it falls behind, it's hard for it to correct itself.
That's why you need the concept of infinity. The long-run behavior. When you have infinity on your side, this is why I laugh. You ever seen people at a casino when they're watching somebody play like a one-armed bandit and it doesn't pay out and they start hawking that seat like as soon as that old lady gets up I'm going to knock her over and take her chair? I love that. It's like, do you understand what infinity is, people? No, you don't. Because what you're expecting is, you've watched that lady pull it 30 times. You expect to be the next person. So in other words, you just saw 5 pulls. You saw 5 rolls of a die, and it went 1, 2, 3, 4, 5, and you're like, I'm totally betting on 6. You're an idiot. Because 6 is only come up 1 in 6 times. There is no pattern of that next number coming up. And this is a hard thing for humans to realize. I remember realizing this in my second stat class as an undergrad. Vince Literature, love you, Vince. He always had food sticking in his mustache. It was kind of disturbing. But he actually said, he was teaching us about this idea in class. And he said, my favorite college football team has gotten tails every single time on the coin flip 13 games in a row. And then he asked us the question, he's like, what would you bet on next? If you were going to bet on what they would get, what would you bet on?
Heads.
The answer is it doesn't matter what you bet on. It's 50-50. Assuming the coin's fair, right, Candace?
Yeah, but
Assuming the coin's fair, it doesn't matter, right?
I bet against the odds.
There's no odds. There's nothing to bet against. It's 50-50. You have no other information. You got a weird run of 13. That happens over time, right? It happens over time. If the coin is fair, big if, yes? Assuming no bias of rolling or flipping. It's 50-50. And then he himself said, but I bet on heads. Thereby undoing the entire lecture. I'm like, you just said! You got a friggin' PhD in this. How could you sit here and say that to me? And you got food in your face. But that's hard for humans. You just felt it, Candace. I gotta go on heads. It's gotta correct. Sure it does, over an infinite period of time, have to correct. How would he have felt after the 12th flip? The 13th came up the exact same way. You're feeling the same way after 12, right? That you have the 13. Should you be surprised when it comes up heads again or tails again? No, because it's 50-50. It's so hard for humans to think that way. Good for you, sister. Thank you. Okay, let's mute this. Let it do its thing. How's it doing? Son of a bitch. It's so pretty. Okay, we'll come back to that one. Let's go to experiment number 2. You have 2 dice. Let's use them both. Repeat experiment number 1, but now flip both dice and write down the sums that you get each time.
This is like press.